this song. It's a great song. Did you guys enjoy the dance party last night? I didn't see a lot of dancing, actually. Not too much. So it was great. Well, I was doing the hackathon, otherwise I would have been there cutting up the dance floor. So I'm so happy to be here, and I'm so happy to see so many people here. Especially, I know I'm up against Ben Lesh, so I know everyone's gonna catch that talk later. So my name is Jen. I'm in developer relations. I'm on the developer relations team at Progress Software. You might know our company as Telerik. We were acquired by Progress, and that is what I do. So I come to various conferences. I can give nice talks and meet nice people, and watch people wear our NativeScript t-shirts. I see a couple of blue t-shirts. I can't see very well, but if you wear the t-shirts, go to the booth, put on the t-shirt, and then you can spin to win. We have like a wheel of fortune, and you can spin to win some really nice prizes. So that is a cool thing to do. So my talk is called Move, Shake, and Drop with NativeScript and Angular 2, named after one of my other favorite songs, which I'm not going to be able to play today because of licensing restrictions. So you'll just have to kind of imagine. But come to the booth, and we'll have some fun. And if you'd like to take a sneak peek of the demo, it's live at pocketrave.me, and you can go ahead and take a look at that website while I'm talking and get an idea of what I built for this conference. So who am I? What is my knowledge? I've been building mobile apps for a really long time. My knowledge is essentially a lot of NativeScript and a little bit of Angular. So I'm trying to learn, like we're all trying to learn, Angular 2. It's been a really fun roller coaster ride watching the NativeScript team, catch up with all the RCs, and finally we're in final and everybody's happy, and it's really been an exciting and brilliant ride. But I also have a lot of web experience. I started out as a web developer about 15 years ago, and maybe 5-6 years of building mobile apps, starting with native code, moving into hybrid, doing some Corona SDK, just a lot of different technologies, and trying to find something that will work great for mobile. So let's just talk a little bit about this concept of being cross-platform. When I say cross-platform, I don't just mean native mobile apps that we build for iOS and Android, but I actually mean building both for native mobile and for the web. So it's a little bit of a technical challenge. So let's just talk about this division between building for web and building for mobile, specifically native mobile. So why would you build a native app at all? Why not just build a web app? There's a lot of discussion about progressive web apps and where this fits in, hybrid, native. These charts kind of show that years of usage data tells us that native and web each have their own unique advantages. Native is known for providing this kind of really rich performant experience, and the data tells us that people use native apps almost 20 times more than web apps on their phones, on their devices. But of course, the web is known for its reach, right? The web is not restricted by device type or operating systems. The web runs everywhere, as we know, and it's a great way to reach a large and diverse set of users. So here's a nice quote by Luke Grabowski. The web is for audience reach, and native apps are for rich experiences. Both are strategic, both are valuable. So when it comes to mobile, it's not web versus native, it's both. Let's just talk about how we can leverage new technologies at our fingertips to build for both the web and for native mobile in the most efficient and painless way. And I do use the word painless with care, acknowledging that this is hard stuff, right? When you are trying to build to satisfy your needs on the web and your needs on mobile, you're dealing maybe with multiple code bases. You might have fragmented platforms. I'm looking at you, Android, what a mess. You might be having to choose between multiple languages, trying to deal with your IDE choice, and then you need to keep features in sync, keep some kind of parity between web and mobile. And this is kind of where NativeScript buys you a certain amount of excitement. So I love my job because I can make memes like this, oh my God, NativeScript. So enter NativeScript. NativeScript paired with Angular 2 is this whole new cross-platform world, and is now open, and it's ready for us. So let's just talk a little bit about NativeScript. How many NativeScript users have I got in this room? I know I met somebody from the Slack channel. A couple of users, hi there. I really can't see a thing, so nice to see you. I met and took a Slack selfie. If you're on our NativeScript community Slack chat, there's 2,000 ecstatic developers of NativeScript. It's a very great community. If you're curious, take a look. It's free and open source. So I thought I'd just give a little rundown about what NativeScript actually is. So NativeScript is a runtime for building and running native iOS, Android, and soon Windows Windows Universal apps with a single JavaScript code base, with or without using AngularJS. I think there's a little bit of confusion. Some people think you must use AngularJS to write a NativeScript app. That's actually not the case. We also have a version of NativeScript that uses plain vanilla JavaScript with CSS and XML. So why would you choose NativeScript over some other technology? So unlike Cordova type of technologies such as Ionic or Kendo UI Mobile, there really is no DOM. So NativeScript does not rely on the browser to serve up a mobile-ish web page. Our elements are native mobile elements, and that's really the big division between a Cordova type technology versus NativeScript. With NativeScript, you're building a native mobile app. Comparing NativeScript to Xamarin, any Xamarin developers in here? I see an awful lot of Macs, but a couple of Xamarin, hi Xamarin back there. There's no cross-compilation at all. Xamarin has this interesting sort of cross-compiler magic going on. We don't do the cross-compilation magic. And unlike React Native and Appcelerator, Titanium Accelerator, very hard to spit out, we do offer direct access to native APIs in JavaScript. So this is really our differentiator with React Native, if anybody's been looking at that technology. But that's really the closest parallel to what NativeScript will offer to you. So why would you choose NativeScript? Well, you can certainly reuse the skills you've already worked so hard to acquire over these many years of battling these battles. You can use JavaScript and CSS. You certainly can use Angular 2 now. Very exciting world opening to us. You can reuse some code. We have NPM modules that you can certainly use modules off of NPM. You can use third-party iOS like CocoaPods. You can go to, I think it's Android Arsenal, use libraries. And then we offer these easy-to-use APIs. There are no wrappers to access the native APIs. You use native UI elements. It is open source. It is free and open source. This is a very new concept for Progress, and it's a kind of an exciting space to be in. And it's supported in Telework Platform. If there's any platform users out here, we just had a release yesterday. So platform is up to parity with supporting NativeScript 2.3 and NPM modules. So it's very exciting as well. Telework Platform offers cloud builds, so you don't have to battle the install locally. So let's talk a little bit about how NativeScript will help you bridge between JavaScript and all of these native APIs. So like I said, NativeScript is not just a set of libraries, rather it's a runtime. Operating word is runtime. It enables you to call the native APIs for Android, iOS, and Windows Universal. And you can think of it, like I think of it, as a translating engine. It uses a prepackaged JavaScript virtual machine to bridge between JavaScript code and native APIs. And to be precise, for Android, it is using Google's V8 JavaScript engine, and for iOS and Windows Phone, it's using WebKit's JavaScript core. So here's a couple examples which run native code on the appropriate virtual machine for the appropriate platform. So let's take a look at the top. So at the top, we have some JavaScript code, which is instantiating a Java Android.text.format time object. It calls its set method, and then it logs the return value of its format method, which is the string 010115. And then at the bottom, we have some code that would run on iOS. We have JavaScript code, which is instantiating an Objective-C UI alert view class. Objective-C has always had these long class names. It's pretty cool. It sets the message property, and then it calls its add button with title and show methods. And when you run a NativeScript iOS app with this code, you would see a native alert. But let's face it, nobody wants to write code like that. That is hideous. Nobody wants to deal with that stuff. Nobody wants to have to write. This is like, we're trying to solve this problem, like not create new problems. We don't want to write, native iOS and Android code. So NativeScript offers you something to protect you from all of that madness. And you can shield yourself like Wonder Woman with NativeScript modules. So NativeScript comes equipped with modules that provide cross-platform functionality, and there are lots of them, there are dozens of them, and they're easy to write yourself. And they follow node modules conventions using CommonJS. And they look a little bit like this. If you wanted, for example, to store a file, you would use the file system module. So here's an example. File system module, you just require it in, and then you pass it a path. And in the background, what the runtime is doing in the background is using this module to call the native Android and the native iOS code. I love this one, create file at path contents attributes. That's a great Objective-C, isn't that beautiful? The NativeScript, you don't have to deal with all that craziness. So just putting it all together for you, you would define your UI with XML, write your logic in like a code behind file in JavaScript, and style it with CSS. So everybody looks at XML and says, not great. So it's really not that bad. I always say, if I can do it, you can do it. So you can go ahead and just write this sort of markup, use your logic with JavaScript, and then NativeScript supports a subset of CSS. Mostly what you need is supported. And when you put it all together, you get magic. Very nice. Okay, there are a couple ways to use NativeScript. Like I mentioned earlier, product placement, you can use crossplatform, and you can, which is a paid product, or you can just use the open source version by just doing a quick npm install globally of NativeScript. Then you can start programming right off of the CLI, and it works really nicely. So like I said, the command line interface is your free and open source solution. You're using your command prompt on Windows, your terminal on Mac. It is open source, it's free. It does require an installation. If anybody came to the hackathon last night, you know what that installation is like. It's not a walk in the park. But once you get it working, it works. It integrates with Visual Studio Code, and we have some community snippets that people have been developing to make your developer experience quite nice. You might want to use the CLI because it gives you more control. You can integrate with existing IDEs, code editors. A community member is working on WebStorm to make a really nice plugin for that. I'm going to meet him tomorrow in Paris. Very exciting. And more technical developers might like this kind of solution. Or you might choose Telerik Platform, which uses a product called App Builder or Screen Builder, more of a drag and drop situation, product placement. It's the easiest way to get started. It does now have full support for NativeScript, and it's a really nice product, actually. I use it myself. It gives you a little bit richer tooling. And I just want to call out brand new Visual Studio integration. Any Visual Studio, not Visual Studio Code, but Windows Visual Studio folks here? We have a very nice plugin for this, and now with more Angular. Very nice IntelliSense. Okay, so 2 ways to write NativeScript, like I already discussed. You can use standard JavaScript, CSS and XML, this kind of pairing, or you can go ahead and leverage Angular 2. So let's talk about what Angular 2 brings to the table. So like Seinfeld, what's the deal with Angular 2? Why would you use it with NativeScript? So for the past year, we've been working to bring Angular 2 and NativeScript together. If you came to NGConf, you saw this slide. I always wanted to try this. When you get angry at your phone. But we're doing this to provide the same experience of building mobile apps as for web apps and allowing Angular developers to reuse their skills. It really is all about skills reuse and code reuse. So what we're doing is taking an Angular 2 code base, mixing it with NativeScript, and producing an Angular for NativeScript, Angular native. Something to think about. So why is Angular 2 so attractive to us? So the first point is that Angular 1 is a technology that does rely on browser DOM manipulation. So unfortunately, or fortunately, NativeScript has no DOM to manipulate. So when Angular 2 decoupled the Angular framework from the DOM, party time, the door is open. The door really opened to us and to a new kind of mobile-friendly tech to leverage this decoupled framework. I always feel like with Angular 2, we're moving away from a framework and we're moving towards a platform. It's a really great time. It's a great time to be alive. And just to compare, if you're writing a standard, what we call vanilla NativeScript app, the markup might look a little bit like this. You have a stack layout written in your XML, and then you have a code behind. We would call it main.js with a little bit of JavaScript. And this code right here would open a native dialog cross-platform when your native button is tapped. See those nice little NativeScript modules there? button. Creates a native button for you. Very cool. Same functionality. NativeScript and Angular 2 looks something like this. It's a little bit small, but it looks very familiar to any Angular 2 developers. In an Angular 2 web app, your Hello World button example will probably be rendered as div button Hello World, but in NativeScript apps, you need to use XML widgets, right? So this example uses a stack layout element, which is really the simplest of our layouts, and it places a single button element within it. So we'll take a look at some of this code later on. Same thing. So this idea that we can write something once and run it everywhere, it's sort of trigger language for people who have been dealing with Java, because that was the promise of Java. But it's still a really attractive idea, and we do have the ability now to reuse a certain amount of code that you already wrote for the web, and then leverage NativeScript to build for Android and iOS to create a truly native mobile app, no web view in sight, beautifully performant, and then you have your web site that you can spin up in parallel. So this is really the beauty of this concept. And to do this, we have a secret weapon. I'm going to be nice. I'm going to tell you what the secret weapon is. You're going to love it. So it is the Angular 2 Advanced Seed. So our community member, Nathan Walker, who is literally my hero, my mentor, my very good friend in Portland, Oregon. So when he gets online, the poor man gets jumped, because I'm in Boston, so 3 hours difference. But he wrote the Angular 2 Advanced Seed based on Minko's Angular Seed. And I just thought I would demo a little bit how easy it is to use the seed to spin up a web app. So I CD'd right already into this code base, and I already did an npm install just to save some time. So all I have to do is do npm start. And that will spin up a lovely website. Ta-da! And then the workflow works that you would, in another terminal window, you would have like npm run start.ios or npm run start.android, and that would spin up your NativeScript apps, and they would look like, if I can find it. Here is what this code base looks on iPhone, and where's my Jenny motion? Come on, Jenny. Here it is. Here it is on Android. So we have this kind of parallel development, whatever that was. And the nice thing is, as you are developing for your NativeScript app, your website has this browser sync capability, so it's live syncing as you go. And if you're running npm run start.livesync.ios, you start to be able to live sync your changes as you go. Same thing for Android. It works really, really well. So let me just get rid of that. Okay. And back to slides. Okay. So for this talk, I decided, all right, let's use the secret weapon. Let's create something really cool. Maybe what I think is cool is not what you all think is cool. But I thought, okay, well, let's create a portable dance party, right? So, because we can, right? So I created this website at pocketrave.me, and I created a lovely logo, and a lovely icon, and a lovely website. And you can visit this live and take a look. So what this is having a particular use case. So what I wanted to do is really separate my mobile experience from my web experience. So the use case on mobile looks a bit like this. On mobile, you fire up the mobile app, which is available right now. Actually, you can download it, and why don't you go ahead and download it if you've got your phones with you. Download Pocket Rave, and you'll see that you can view Pocket Raves that people have created. There are a bunch of community-created raves already because it's been live for about a week. And you can just view them on mobile. You can't play them until you go onto the web. But what you do on mobile is you create the Pocket Rave. So I used some plugins that are also community-generated. You draw an image, and then you pick a track out of SoundCloud, and you pair the image with the track, and that creates your Pocket Rave. On the web, we then play the Pocket Rave with the SoundCloud music, which I can't play, and we have a kaleidoscope using CSS animations. So we have this kind of cool kaleidoscope, and you can see all of this live right now. So let's talk about the making of Pocket Rave. So the tools that I use the SoundCloud API. I used several mobile plugins that are generated actually all of these plugins are community generated. Drawing Pad, which is actually generated because we needed to do a banking app and we needed to capture signatures, and I totally perverted it for this, for this use case. It's like, that's so boring. Audio plugins so that you can listen to the tracks coming out of SoundCloud. A play-pause button, which just toggles playing and pausing. Font icons are in there. Font icons are available actually cross-platform. And then the back-end service that I decided to use is Firebase because I love Firebase. And then I have CSS animation that I borrowed from a really cool code pen. Somebody just turned on the light show. Spoiler alert. I use the advanced Angular seed that I just talked about, Firebase for data and image storage and hosting, and then the hardware integration, which we'll talk about in a minute. So that's with a particle photon, because I like hardware. So building cross-platform with the advanced seed, what I wanted to go over, actually this is the meat of the talk now that I've been blabbering for 25 minutes. The meat of the talk is right here. Building cross-platform with the advanced seed, there are 4 concepts to understand. And then what I wanted to talk about is the folder structure, naming conventions, how you fork the front end, and this concept of opaque tokens, which helps you shield your web and your mobile experiences a little bit. Because if you need to use plugins like the play pause button and you just import that directly into your code base, your web will choke because it does not know what to do with that. So we're going to talk about how to kind of protect how to share and how to kind of fork and protect each platform from the damage the other one can do to it. Okay, so let's talk about folder structure. This is really the architecture of this seed. And the way it works is there's a symlink, actually, between NativeScript app and the source client app. Concentrate, people. So that in your frameworks folder, you can develop in either place, and then the code is reflected. So that's really cool. And this allows you to go ahead and deliver your NativeScript app to the app stores when it's time from within that NativeScript folder, because at some point, you're going to need to go ahead and build your NativeScript app and upload the resultant APK files and IPA files to the proper store, Google Play or iTunes. And you can actually see, like physically see what the symlink looks like when you open it in Finder. So it's right here. And there's also another one you can see in the assets at the bottom in the assets folder, so you can share images between web and native mobile if you want to do that. Okay, second point, naming conventions. Let's talk about file naming conventions, and this is kind of the innovation of this seed. Actually, Nathaniel Anderson and Nathan Walker, that's not confusing at all. The 2 Nathans of our community worked together to kind of settle this naming convention and how it works. It really allows you, by leveraging the naming convention of the files, to differentiate your web and mobile presence. So here we have a situation where our about part of the website, it really only exists on web. I don't have it available I don't need it on mobile. So I just have it on web, so all I have is about.component.html. And in the create section, I do need it on mobile, so I need 2 files here. I need create component TNS, Telerik NativeScript HTML. That's the NativeScript file, that's the front end. And then I have create component HTML, and that's the web bit. It's not used on web, but since I need the NativeScript component, this is just the way they decided to build it. You have, you need it on NativeScript, you also need to have a kind of dummy web file there. If you need something on both, you would have home component TNS HTML, home component HTML, because you need a home page on both of your platforms. You can also you can also include different files, different CSS files, that will allow you to style your mobile and your websites differently. So we have home component CSS, which is paired with home component HTML, and then we have home component TNS CSS, which is paired with home component TNS HTML. It all works. It's great. Actually, this seed also works with Electron, so I believe there's a naming convention around that too. I haven't spun it up because I can't figure out a use case for a desktop with this particular application. Maybe you guys have some good ideas. Okay, so the third point is how to fork the front end. So although the seed allows us to share a lot of code in the code behind file and the components file, the routes, and the service files, the front end is always going to be a little bit different on the web and the native mobile. It's different probably for a couple of reasons. A lot of people say they want their website and their mobile site to look exactly the same. I think that's not the best idea I ever heard in my life. You need things like action bars on your mobile app that you're not going to really use on the web. So on the web, we use HTML. We have semantic markup. We have a nice header, divs, H1s, Ps, ULs, LIs, all that good old HTML that we've been loving for so many years. However, on your NativeScript homepage, you're going to have NativeScript components, modules. So we have an action bar here. We have, in that action bar, we have some action items. We have a button. And then we have this interesting wrap layout that allowed me to create a tile layout. So we have a wrap layout. In that wrap layout, we have a nested stack layout. So we show the image of the rave that someone created and then the label with the name of the song that was paired to it. So let me just go ahead and do a demo. And I'm going to mirror this phone, my big, big iPhone. OK, can you all see? I'm going to open up Pocket Rave. Nobody cares about Spotify. OK, so we are pulling some images out of Firebase right now. So this is how the mobile app looks right now on iOS. Oh, people are creating some interesting Pocket Raves. 4 just came through. That's nice. OK, so I have a little area here where you have some instructions on how to proceed. And then you would go ahead and create a new Pocket Rave. I have, this is the drawing pad plugin paired with a color slider plugin. So I would go ahead, I'm going to go ahead and create, let's see, I'm going to make this a little bit bigger and just do an Angular image. So I'm going to pick a color, I want that nice Angular red. Where is it? Yeah, no, yeah. Okay, and let me see if I can make this shield. Should have brought my stylus. Yeah. Let's make it a little bit better. And then there's like this line. Okay. Good enough. Ship it. Okay, I'm going to save it to Firebase. And although I would love to, have a great, great song, I did find one for you. Actually, Jeff Cross saved my demo because he uploaded this amazing song clip. Angular 2 is very exciting. Let's find some tracks out of SoundCloud. Come on, Wi-Fi. There it is. Now, if I wanted to play it, I would just use my play pause button. It's going to load up. I'm going to go ahead and just select this. All right. Nice crash there. But you can see how it was saved, and there it is. So in the home page, it's saved. Now, because Firebase is real time, yeah, nice. I absolutely knew somebody would do that, but anyway, very nice. OK. Way to throw Jen. Where was I? OK. Presenter view. Danger of live demos. So obviously, I need to create a login page. And I need to create a little pop-up that would oblige people to put their name. So you've got to own that image. All right. Anyway, that's how Pocket Rave works on mobile. And I'll show how it works on web in just a second. But what I want to talk about also now is this concept of sharing code behind the scenes. So once you get away from the front-end files, which we just talked about, the code sharing really can begin. So we only have one TypeScript file to control the experience. And this is an example of one of these code behind files. This is your component page, and this is actually the home page. And it initializes Firebase, and it grabs all the rave pairs from the Firebase, and that's really all that it does. And you might have noticed some funny shenanigans going on this homepage. So you notice that I have this on line 4, I am importing a token, a file with tokens in it. And then in the constructor, I inject these tokens. And then on line 29, I actually start using these tokens. So what the heck are tokens? What is up with that? That is weird. Opaque tokens are actually the secret weapon that allows you to really make this Angular seed really work nicely. So here's how they work. Once you start building your mobile app, you're going to have to shield your website, like I said, from the mobile plugin and any module implementations that you're going to have to use. For example, I needed, as you saw in the code before, I needed the frame module to be used for the mobile app so that I can make certain things happen and only happen on the iOS action bar. So it's quite specific to iOS. I didn't want the back button to constantly show on the home page, so I'm going to use a little bit of native code to hide that. But if I import that stuff directly into my TypeScript file in my create folder, the code is going to try to run on a website and it will break the website. It will fail. Okay, so what are you going to do? What's a person to do in this situation? Well, what you can do is you can leverage Angular's concept of the opaque token. And just to refer you to a nice article by Pascal, I just made a little bit.ly so you can refer to this stuff. So in Angular 2, we can either use string or type tokens to make dependencies available to the injector. However, when using string tokens, there's this possibility of running into naming collisions, as the same name might exist for a different provider, and especially when you're using these third-party libraries. And opaque tokens solve this problem. So standard tokens are often simple string primitives, right? But opaque tokens are different. They're actual object instances. So using opaque tokens allows us to create string-based tokens without running into any of these naming collisions. So it's really, really convenient, and it really allows us to separate and to protect, the platforms from each other. They're really designed to allow developers, to protect their code from name collisions, and we use them in this code environment to stop the web and mobile platforms from colliding when certain libraries aren't supported. Okay, so here's an example. This is the setup. It's a little bit of creating of files and sharing of tokens, but I just wanted to walk you through how to set up this thing, because actually Pocket Rave is the only use of opaque tokens in production right now in this environment, using this seed with NativeScript, and so it's a revolutionary platform. I'm going to make so much money with this. It's crazy. So where you start is you go to your framework's core folder and you create a file listing all of the tokens that you need to create, and then you store them in this tokens_shared constant that you see right there on line 16. And then in separate files, you list out the tokens that need to be available for web versus mobile. So here, we have tokens for the web listed in the tokens web TypeScript file, and then on tokens native, you can see I use a bunch more for my and these are all the plugins that I'm using on the mobile app. So we hide, so you're basically allowing yourself to hide these two lists, these two groups of tokens from each other, because we're adding them to these separate arrays called tokens web and tokens native. All right, so step 3 would be just to start creating files. Sorry, that was step 2. Step 3, use the web tokens in the web module and use native tokens in the native module. So you have modules for each of your platforms, and you need to inject the proper tokens for the proper platform. So here we're just injecting tokens web, and over here we're injecting tokens native. It's that simple. And then step 4, on the front end, you just use what you need. So in this file, this is a home component TypeScript. We're back to that home file that we saw earlier. So you import the dialogues token and the frame token. Those are just the tokens that you need in this situation. And then you inject them into the constructor, inject dialogues, inject frame. And then you use the NativeScript frame module as you like. So I also have a little extra bit of protection here in my config. I'm just checking whether I'm on a mobile native platform. And then I'm able to use my token and specify it for iOS. So it's quite specific. I don't need it for Android. Okay? And that is it. That is it. I just wanted to explain those concepts of how to use the seed to go about creating a certain amount of shared code, how to fork the front end, how to use these opaque tokens to really protect the platforms from each other. But basic concept of this thing is that you can share as much as you want, and you can really create something interesting. So why don't I go ahead, speaking of interesting things, and show what we created. Here it is. So Angular 2.
Angular 2 is really exciting. New models for UI development, and I'm very excited. I do like Angular 2. I think it's a fantastic framework. Angular 2 is really exciting. New models for UI development, and I'm very excited. I do like Angular 2. I think it's a fantastic framework. Angular 2 is really exciting.
It goes on. So make some nice pocket raves. I'm going to go to Firebase, and I'm going to delete that naughty picture. Because I have the power. But just, I hope the light has gone on for you. I'm going to go ahead and start a light show. Did the red go on? You have to tell me. So here's blue. You can't really see what's going on. Yeah. Green. This is a photon, which has Wi-Fi connectivity, and it's actually tethered to my phone. But if anybody is interested in hardware, I'm happy to chat with you at the booth. It's a little out of scope, but if I have the opportunity to do any hardware integrations, I never can really resist. So all we need is a lot of alcohol or something to make this the true experience that it can be, I think, or other substances. So, trippy demo. I hope you enjoyed it. Come chat with me at the booth. Create your pocket raves. Nice pictures. And thank you for coming to my talk.